A multi-pronged approach to CMP wastewater recycling. MN200 special topics in engineering. At MassBay, I'm Brandon Joy.
I'm Sean Curtin.
I'm McMullen.
And I'm Wyatt Maurer.
Problem definition. The core problem is the chemical mechanical polishing, also known as CMP. Copious amounts of wastewater with toxic PFAS, heavy metals, and abrasive nanoparticles. Research finding summary. The purpose of the research was to find methods to realistically reduce CMP water usage and environmental pollutants.
Research findings continued. Currently, many large chip fabricators in water-constrained locations like TSMC and Samsung recycle between 70 to 85% of their water from the CMP process. These fabs have different approaches to recycling large portions of their wastewater, but there's a reluctance to share methods for fear of revealing proprietary information.
The process of recycling the sludge mixture of concentrated chemicals and metals is not as developed as fabs' abilities to reuse water. Three of the most realistically recyclable materials contained in CMP wastewater sludge. The three most realistically recyclable materials contained in CMP wastewater sludge are cerium oxide, copper, and silicon dioxide. Our research findings and conclusion. We should focus on creating an industry-wide organization to follow for the sharing of CMP wastewater recycling methods. And we should focus on recycling methods for copper, cerium oxide, and silicon dioxide. We didn't use much AI other than default Google AI overview. We used a lot of school resources. Our selected solution: encourage collaboration for water recycling, justification for choice, spreading already existing water reuse technologies, and developing sludge treatment and recycling methods that can realistically help address CMP wastewater. Organizational aspects of your solution. Industry-wide organization to spread water recycling and treatment. This organization will help bridge knowledge and gap between companies.
We established 4 success criteria at the beginning, using accessible technologies, realistic cost to implement, scalability, and realistic complexity. Our solution meets these well. Sludge recycling is one of the most researched processes in chip production. The technology is already in production, and the equipment is standard and relatively accessible. The complexity is a challenge, but it's achievable. To validate our solution, we would do 2 things. First, conduct a financial audit comparing the implementation costs to the overall project cost and any sustainability credits earned. Second, search for and benchmark similar sludge treatment operations that are already happening today in other industries. Our testing plan has 4 phases. Phase 1, a 1-month baseline audit where we partner with a fabrication plant and start developing extraction models while reaching out to stakeholders. Phase 2, a 2 to 3 month small-scale pilot testing sludge recycling yields and recruiting a small number of fabs to join the collaborative. Phase 3, a 6-month large-scale pilot testing sludge extraction at fab scale and organizing the first annual conference to promote the collaborative's goals. Phase 4, analyze ROI by comparing results to baseline.
Problem-solving process reflection. What worked well was dividing work within the team and not having judgment on new ideas and ranking our ideas based off the criteria we set out with. For what we could improve, we think meeting more regularly at a predetermined time would have been more effective for scheduling for everyone. The one big thing we dealt with was found it difficult to do hybrid approaches to meetings where there's one person web chatting in while others are in the room, but we made it work very well. Transfer of learning. By taking part in this PBL, we learned how to approach complex subjects as a team to find a solution. The project was a textbook use of engineering design cycle, which is used on a variety of different products. Waste reduction and recycling as a process is incredibly important in many industries, especially as resources become scarcer. If we had the opportunity to do more on the project, we would want to be able to test our ideas further, produce our own filtration methods. The only change we would want to make when it comes to teamwork would be meeting more. We all have busy schedules, so it was difficult sometimes. We faced a few minor challenges. One of the challenges being trying to find a solution that would be the most productive. We each did individual research, trying to find the best solution out of all the proposed ideas was hard, but we eventually did it.
If you have any questions or comments, please leave them below and we'll try to get back to you. Thank you for listening.
Thank you for listening.
Thank you for listening.
Thank you.